Good morning and welcome to today's webinar. It's Precast for Industrialised Construction, brought to you by Trimble and Punch Consulting Engineers in collaboration with Build and Learning. Quick summary of today's agenda. I will be kicking us off with some introductions for part one. Part two, we have Tekla structures for precast, model data to drive fabrication. So we'll be diving into a technical demonstration of Tekla structures focused on precast workflows. Thirdly, we have a case study with Punch. So very kindly, Punch Consulting Engineers will be taking us through a recent study to help share insights and their expertise in this area. Lastly, on point four, we have Q&A. So once we've covered the strategies and the tools, we'll wrap things up with a live Q&A session to tackle your specific challenges. Introducing our presenters then. The voice you've heard without a name so far is myself, Richard Arnott, Business Development Manager here at Trimble Tekla. We then have Stephen Jones. So Stephen Jones is a sales engineer here at Trimble Tekla, and he'll be taking us through part two of our agenda. We then have Aidan O'Connell, Technical Director at Punch Consulting Engineers, and Ben Geary, a software developer at Punch Consulting Engineers. Together, they'll be taking us through part three of our agenda. And the collective presenting team will be there to answer your questions at the end of today's session. So, before we get into the webinar, I have to start with a little bit of housekeeping. So feel free to ask questions during the webinar using the Q&A button. We'll aim to answer as many of those as we can during the Q&A session towards the end of today's webinar. The session will be recorded, and we'll share the recording with all registered participants in the next few days, so watch out for that. And also throughout today's session, we'll have a couple of poll questions along the way, so we'd absolutely love your input on those. A brief introduction to Trimble then. Trimble is all around the world supporting construction. We empower customers to drive productivity and progress with connected hardware and software solutions. Behind the scenes, we have approximately 12,000 employees, over 35 plus countries globally. And specifically within the UK, we have over 500 employees. With all this in mind, we are the fastest growing global construction software provider in the world. So a little bit more about that growth and how we've achieved it. Trimble supports every phase of construction lifecycle, and we deliver this through software and hardware products which aim at different sectors of the construction industry that go from concept, develop design, detailed design, site processes, and through to operation and management. So a lot of the software solutions which you can see on this screen will likely look familiar as the UK market products. But importantly together, they form an ecosystem designed to reduce coordination errors and minimize the risk of costly rework. These solutions also work alongside our wider portfolio, including our estimating software and field hardware. Today, however, our focus is on Tekla structures, also Project Site, a construction project management solution designed to bridge the gap between your office and field, and we'll also show how both work with Trimble Connect. So, Trimble Connected Construction and what it enables. So connecting your teams enables productivity. Using your data to make better decisions reduces errors. And making information clearly visible across the business ensures clear communication through digital processes, which can then also enable a clear audit trail. We will demonstrate today how Tekla, Trimble Connect, and Project Site connectivity can change the way you deliver construction projects, connecting teams along the way. So by adopting connected workflows for your teams, as mentioned, you can bridge a gap between those teams, ensure efficiency for delivery, and as per our mission, we strive to make you more profitable with these connected workflows. I'll now be handing over to my colleague, Stephen Jones, to take us through part two of the agenda. I hope you enjoyed today's session, and we look forward to reviewing your questions throughout. Over to you, Stephen.
Thank you very much, Richard. Hi there, I'm Stephen Jones. I'm going to take you through from here Tekla structures for precast and looking at the model data to drive fabrication. So some of the challenges that we're facing within the industry are revolving around the material wastage, project pressures for budgets, being on time, the construction cost for rework, and also job site work that's unproductive, which is generally driving our productivity down across the board. What we're trying to do is facilitate these industry trends in order to help customers who are working towards offsite automation, sharing of information, to make the process as seamless and as pain-free as possible in order to facilitate these industrial fabrication processes. So what do we offer? So Tekla Structures itself is a multi-material modeling system that can hold all of the model data that's required for an as-built, fabricated and constructible model, and push that data directly through to the factory itself. What we're aiming to do is help you plan, improve your accuracy, mitigate any risk, etc. And you bring the single source of truth for the model information that you're going to require to build your projects. The LOD level of design that's within Tekla Structures, or level of detailing in Tekla Structures, goes right down to nuts, bolts, washers, welds. We track and trace everything through a numbering system that allows us to push those fabricated items through to drawing production, sign-off, approval, and then all the way through to production control for the machine control software on the shop floor, utilizing things such as PXML, UXML, BVBS, and so on, in order to ensure that what you are modeling is what you're going to build, and then what you're going to be building is then traceable, it's auditable, and you can check out the documentation and keep a store of all that information readily available for your project teams. So we're going to look at some of the integrated work, so it's not just with Tekla Structures, but also with Trimble Connect and Project Site. And with the Tekla Structure software itself, I'm going to show how this can be used to link between those pieces of software and allow you to create your geometry, utilize automated detailing tools and AI drawing, documentation creation, model-driven data for production, I mentioned earlier PXML, and controlling that via our hub through Trimble Connect and then Project Site, which we saw just a moment ago. So I'm just going to jump into Tekla Structures, so I'll get that loaded up now. Okay, so here we are in Tekla Structures, and we're going to look at how Tekla Structures can help the industrialized fabrication workflows. We're going to start off with just looking at how we would share and collaborate between different areas of the workflow. So, for example, here we've got a fully detailed model. We're going to be, already created GAs for this. Now, I need to share this with my project managers and, let's say, my production teams in order to be able to put the required approvals together and so on. So we can make this really quite simple, because between Tekla Structures we have Trimble Connect and we also have Project Site. So what I'm going to do, or what I would do, is I come into my documents, I go and create some, for example, GAs, some elevations and some plans and so on. And I would upload these through to Trimble Connect with the model and also the drawings. This can be done in the document manager at the print stage. You just go to print and it puts those files linked directly into Trimble Connect. So if I have a look at Trimble Connect inside here, we can see these are my PDF drawings. There we go. And they've been sent through to Trimble Connect. And also, because this is the hub between our Tekla Structures model and also our project management system, we're able to go into our project manager, Project Site here, and here in the files space, I've got my library. This links directly into my project of Trimble Connect, which is here. And there we see drawings, and then I've got my GAs and so on. And I can then upload these drawings from here into my project management space in my drawings area. And at this point, I can assign these through to have them checked and approved. So, for example, I can come in, let's go and pick, for example, one of these foundation plans. I can flip through them quite quickly. I can see exactly what's going on in my drawing. And I can then go and put RFIs, I can put links in, and I can put various texts and so on and markups, and then issue these for either further information or for approval. Okay, so that's where we would go from here, and then continue on back when we've got those approvals into Tekla Structures. Okay, so back over in Tekla Structures, I'm just going to run through a quick example of how to create, for example, a wall elevation. The reason behind this is because I want to show some of the tools that are available that aid this standardized production workflow. So as we can see here, we have columns, beams, wall panels and so on, and Tekla is built with various different tools to add these elements quickly and easily, as well as adding the reinforcement to them. But we want to try and automate this. And there are various different tools that we can utilize. I'm going to show a quick example that brings a few of these together, because what Tekla Structure specializes in is automating specific tools with specialized macros and components. So, for example, we've got various different tools for beams and columns, panels and walls, and so on. But then we could bring those all together and then push those directly onto particular elements, such as a set of commands that will run for our beams, and a set that will run for our columns, and a set that will run for our walls. Now I'm going to go and concentrate on a wall area, and I'm going to do this over here. So we're in a bit of a clean space, and I'm going to utilize my reference models over here, and let's just bring this reference model IFC in. I'm going to basically recreate this wall panel structure in that location using the reference information that I have from this IFC. Right, let's make this a little bit easier to see. So I'm going to open up my model views, and in my sorted space, I'm going to look at my elevation on the 7th elevation here, and I'm going to start to create this wall panel layout using the IFC that we've just seen brought in place here. Just make this screen a little bit bigger, like so. I'm going to start off by creating the wall geometry, and we have, like I mentioned before, specialized tools for column beams, panels, slabs, and so on. And in here we have this wall layout tool. This tool itself allows us to create different types of wall products, so panels, cross wall. We've got double walls, we'll say twin wall, and also sandwich panels and so on. I have the same setting in here for this that we can load in. And here I can define each of my specific layers. I can give those layers different properties, different offsets and different detailing elements and so on, and standardize that insertion at the very beginning. I'm going to keep this really simple at this moment. But also I can also set this up ready to go directly to production. So this is looking at Unitechnic, PXML with progress, and so on, being able to send out this information correctly in order to be read by machine control software. Right, so I'm just going to apply those for use, and let's just get that away. And I'm just going to start to model this wall element in. I'm just going to follow the space here. Like so, you can see the wall's just got in. Now, in this instance, I've got the wall at one level. This is set up as a 3-meter wall. But what I'm going to do is I'm just going to open this up, and I'm going to set it by the levels. And the reason why I want to do this is if there's any design changes, I can tell my system to follow the level. So if there might be a level change, for example, that's come through, and I'm going to say, actually, I want to go from a particular grid level that I've set up in order to get my design and my basic geometry out as quickly as possible and respond then to any changes that may occur. So I'm just going to modify to that, and there we go. It's now scrolling up to that top level. Now what I want to do is, using the IFC, I also then want to start to put in my openings, my doors, my windows, and so on. I can see where they are in the IFC, and I'm going to use that information and the quick editing tools that I have on my, what we call a mini toolbar, where I can either add splits, change the outline geometry, detailing, boundary offsets, and so on. I'm just going to use this to create openings, and this is going to go through all layers, although I can set it to specific ones if I need to. And then it's just a case of tracing through those openings, like so. I can also then, if I need to, copy these to other locations very quickly and easily along my entire wall layout. Okay, so I'm going to just move those along there and then come up with it's all done. There we go, nice and quickly added all of my openings, copied them through. I can also see where they are in my elevation, and I can actually control them from here as well if I need to. Now, what I'm going to do is then go to my tools again. So like I said before, we've got some standardized tools that allow us to create rule-specific operations directly onto the walls, floors, columns, beams, and so on. So with my wall layout, we have a nice elementation tool. And this is pretty generic, but what it does is allow us to very quickly break down based off of a set of rules, starting with, for example, in this instance, I've got a 6 meter maximum length, and the next drop will be 5.5 and then 5 meters, depending on how the logic breaks down the wall and its openings. You can see here, we can set out what the openings will be, and we have to avoid them in this instance, and the direction of travel as well. I can also set where the seam goes in. I can set it to actually put in a detail as well. So my horizontal seams. It's not correct. I want to change that there, actually. For now, I'm going to set these like so, but I could say my vertical seams, I want there to be a connection. I'm not going to do that just for now, but you can see how we can then create these. I've told it that I've got a max height of 3 meters. And all I need to do then is, if I come in, I can pick my wall panel, like so, and then just say, create the selected walls. And you can see there very quickly, it's created 8 new seams, one selected wall layout that I picked, and if I say, okay, let's just go and have a look here. So you can see here, it's made some standardized panel sizes. There we go. And also, excuse me, create them with what we call seams. So, for example, here, I might not want this to be the situation. The reason why it's happened is because the window opening is slightly different to the door opening. But if I pick this element and then come across to my wall layout area, I can actually say, look, let's just go and change this. I want that to actually match up. So I'm going to match it up like so. There we go. At this point, what I want to do is set in some details. So what I'm going to do first and foremost is going to check my elements to make sure I've got some standardized numbers, and I'm going to just run my numbering. And this will go through and it'll basically compare everything against everything else that I've selected and tell me that I've got specific numbers and have them assigned directly to those elements. Okay, there we go. So the sandwich walls are in, the installations are being numbered and so on. The assemblies there for the sandwich walls are all there. We've got 69, 70, 71, 72, 70 and so on. Like so, and then there's various other part elements that are being numbered. I'm going to assign those numbers now. And what I'm going to do is just quickly check those. So I'm going to go and pick here, not the wall layout. I'm going to pick them as an assembly like this and just check my number very quickly. It's just landed there. Go. Okay. So sandwich wall 69. Let's check this one. 69, and for example, there we have 69. Excellent. So they've all aligned very quickly and easily. Now this allows me to then go and start to create my drawings of my panel, my formworks and so on. But what I want to do first and foremost is start to add in some details. I'm going to do this by currently turning off my template and using something called the detailing manager. I'm going to focus up here. We can see this across the entire still wall layout. So each of these individual elements has been broken out because of those seams, but it's still managed at the top end by this entire wall layout. So, like I mentioned earlier, we've got specialized tools that do specific jobs. We can bring them all together in this detailing manager. So here, for example, I can pick up my detailing manager and I can say, right, give me my wall panel layout that I wanted. And I've set this up already to go and use these specific rules and filters on the things that I select, and then pass a specific set of standards that I've saved into each of these tools. So there's the wall panel reinforcement tool. I've got my mesh tools, my propping tools. I've got my pins for my thermo pins to go between the layers of my insulation and my wall, my lifters, and then my outer mesh for my sandwich walls. So all of these are, instead of having one tool that tries to do everything, we've got several tools that do a very specific job that I can then lay out rules to. So for example, let's just say we look at the mesh. Here we go. And this mesh bars tool is what's being loaded in. And if I come to that mesh bars tool, there we are. And the settings that we have. So I've got my front, there we go, back grid, there we are. The reason why I've set it like this is just for the demonstration, but essentially I've got these B10 spaced at 200, but I'm setting this up to work directly with my machine in the factory that's going to do my mesh welding. So when I send this out via Unitechnic or PXML or so on, I know that it will be set to work to the machine that I have in my factory, allowing me to very quickly ensure that the design that I put in or the rebar that I'm putting in only works with that situation, and I cannot put them into other places. And this similar things will happen with the detailing managers, other tools that are in, for example, embeds, where we are loading in, excuse me, our wavy tails. The wavy tails coming in and it's being placed at the center of gravity by 5th points. I can also have it set to run with the total assembly weight, which will then pull from a list of assigned lifters that will only be put in place for a specific weight of panel. So I can use 2.5 lifters in less than a 5-ton panel itself, so on and so forth. So I can use those again it will automatically decide based then off the weight, and it will tell me, and it will put the one in that's correct. So let's get back to that detailing manager and just get that opened up. Okay, so the benefit that I have here now is because this is running with filters, I can literally pick the entire wall elevation and just say I want to create on all the selected objects. And there we have it. Okay, fantastic. So I'm just going to leave that out of the way, but you can see that this has done this for every single panel. It's individualized them. So if I come in and have a look inside, I can see all my lifters are in, and they're all designed based off of the panel, and the parameters that are set of each individual tool, and then the panel that it's going into. And even then, once that's in, that's given me a star of a 10. So at that point, I'm able to come in and say, look, I might need to add in additional reinforcements. So let me just go and isolate one of my panels like so, and let's just say showing selected. Okay, so I'm in here, and what I want to do, so one sec. There we go. So what I might want to do is actually come in, and maybe I've got a socket that's not quite in the right place, or for example there may well be a clashing piece of reinforcement that's gone into it or something like this. So I can come in and check that very quickly and then make a change. So for example, I can pick up the entire thing, or I can go into each individual element itself. So for example here, let's pick this up, grab hold of that socket, and then I can grab and drag and move this into a particular location that will then suit. Similarly, I might well find that I need to do this for my mesh. I might need to add an additional bar. I've got bars here and here, nicely, like so, but then I might need to add another one in this location, let's say. And again, I can drag and move those into the location I want to drop them into. The benefit, obviously, with this then being set to my grid is that also, if I move it, it will only snap to an allowed grid position. It will not allow me to snap outside of those bounds, so it will always work with my mesh welding machine. There we go. Okay, so what we're then going to do is we're going to start to look at creating our drawings for fabrication, and we're going to use our AI cloud fabrication drawing service. I'm just going to reset my view. There we are, and then we'll have a look at how this system works. So I'm going to select these panels at this end. I'm going to set them as assemblies. I'm going to make sure my numbering is up to date, and I'm going to run through my cloud fabrication service button just here. Once I've done this, what will happen will be Tekla will put these into a list, and it will go through and suggest to me the most relevant drawings that I can use based off of my own drawing requirements. So I will have uploaded my own drawings, which you will then use as a template and come and find a best match for the one. So you can see here, this is linked it to a drawing that I've done previously. Could be in another model, could be another job, SW30, SW28, and so on. And it's linked those to these. Now it's also picked up those supports because I've accidentally highlighted those, so I don't want to use those. But what it will also do is it will give me a top 3. So if I pick on here, this is what it has picked. But then these are the other options that are available to me. So the more that I choose or change these options, the more it will then start to offer them up to me in the future. So I'm going to go ahead and hit create now on these drawings that I've got selected. Okay, so that's going to come from here. And there we go, let's just hit create there. And it'll go off and create those drawings for me. It's actually pretty quick, so I'll come back in just a second with my drawing list. Oops, not moving. There we go. And there we can see our kind of drawings here. There they are. All come through. So let's get one of these open. And there we have it. So let's have a quick look here. There we go. And what you can see then is the finished drawing. This is obviously the clone from the original template that we put onto the AI drawing. So it's been matched to this particular panel as the best match. I can obviously still do my edits if I need to. I can add in extra details, extra views, and so on, and then even re-upload this to become another selection for ongoing jobs to create a more accurate result, let's say, over time. So there's the panel ready to go. And what I'm going to do now is just get this now uploaded through to Trimble Connect. We're going to use Trimble Connect again as the central hub that's going to allow us to share this information through to those guys that are on the shop floor in production, who will be then producing these panels, but they're then going to use project site to then send out the drawings for checking purposes in order to make sure that they've been approved, they're absolutely good to go, and then have them verified and sent back. So over in Trimble Connect, just shut these down. I'm going to push this through to Trimble Connect via my print procedure, so I can shut down my drawing, and these drawings are then linked to Trimble Connect via printing and uploading. So let's say here we've got this one, 1, 2, and let's go that one there, I think it was, yeah, and then we can just say, right, okay, let's print those out. And inside the print dialog, we have the project links directly into Trimble Connect, and I can upload these drawings and link them directly to the model objects inside Trimble Connect itself. So if I hit print and upload, I click that just there, and it will then send those drawings up to Trimble Connect. And we should get a little notification. You can see that just popped up here. There we go. So it's uploaded, and that's now complete. There we are, and then just click that to open up into Trimble Connect. Excellent. So that's coming here, and these drawings then land in our shared space. So we can look in drawings, cast unit drawings, and in our shared space. So we can look in drawings, cast unit drawings, and we can see those that have been pushed into this area here. I can obviously further sort them if I need to, but obviously with project site, this is also now accessible to those people who are going to go and check these drawings via the file library. So I can come in and then say, right, okay, I've got these for checking, and I want to make sure that they're okay. I can flick through them really quickly, and I can add any comments that I need to, and then pass them back through that same process once approved, for them to then go into the production space. So inside here, production manager's got the approvals. They then want to commit this information to production. So they're going to inform the guys in the drawing office that they need to produce the production files in order to get that ball rolling and get the information sent through to the machine control software. So we can do this via our status sharing space in here. And what I'm going to do is just pick out some of these. So if I said I'm going to pick these elements here as assemblies, I can then say, right, I've got these, I've got the drawings attached, I'm going to enable them, effectively triggering these to be then put into production on the drawing office side. This is all instant, so obviously if I go back through to Tekla structures, what I'll be able to do, if I pop that out of the way there, get back into Tekla structures there, let's just close these out of the way, like so. And the state sharing is also active inside Tekla structures itself, so I'll be able to see those go in, and it's just kind of like the status of the model. You can see there they've been enabled for production, which is great. So now on my side, I know that I'm good to go with these, so I can select these elements as their cast units, and I can then start to push this through to the machine control files. So we have direct exports for BVBS for the rebar, for bar bending, cutting, and so on. Also Unitechnic for the Unitechnic file operating system for machine control software going into an automated precast factory. But also most recently, there's been the UXML and PXML developments by both Unitechnic, Unicam, and also by Progress. So inside this space, I can run my production export. I can set the files that I want. Then the standards that I need to use, have them loaded in, and then come in, put any specific information that I need for my factory, which obviously would be saved as part of my standards, and then just go and export those files. Once I've exported them, I'll be sharing them directly with the production team. So those files are saved directly into my model folder. So here, they're in my PXML and export space, so they're all here. And I can upload those straight through Trimble Connect, which means instant access in the production office, and also availability for those that are keeping track of all of the data that we have for our entire project in Project Site. So if I come to my Trimble Connect space, let's just click there. These can be then seen in our Explorer, our PXML files for production, and we can then take those with the drawings that we've already got already. I've already split them down. This is just a bare example of week 1, week 2, week 3, really basic. Then we push that through to our machine control software, and then pipe it through the automated plant, pushing it onto the information through to the bed, to mesh welding machines, to automatic rebar placements, and so on. Dependent upon the machine, the factory setup, we can then handle this really quite quickly and easily, and keep a control of exactly where the files are, what's been happening, what's been produced, and so on. So, for example, at this point, I can say, right, these guys have been committed to production. Great, so they're in. In Tekla structure side, I've committed them. Missed a step there. But then here, I would say now, actually, these have been started. So if I say these are now started in production, we can then come into Tekla and we'll be able to see those updates happen in real time. I've done this. There we go. It's just immediately come up and told me these are now in production. And again, I can keep track of this, and this would be colorizing my model as I go across the entire job, and all of these statuses and dates will be then recorded on these panels, so I can keep track of everything that's happening in my job. I'm just dropping back into Trimble Connect here. Now, we could say there might be an issue with one of the panels, and we might want to pause the production. There might be something where, or even coming out of production, might have had some damage or something like this. I'm going to pause that on this particular element. In this space, I'm going to show only that element. I'm going to move this around so I can have a better look at it. And I'm basically going to convey some information back to the drawing office. Maybe I need to do some additional checks. I might have to do some rework, or something is possibly being recorded as being wrong. So in this space, I can then say, right, I'm in a production team on the shop floor, and I'm going to push through some information on this particular object. I'm going to create a new, what we call BCF topic. I'm going to say issue with panel, and fill out the rest of this like so, and then just save that there. This will create me a new BCF topic, and that will now be available between all the platforms that can read it. It can go to project site, where we can issue this and maybe attach it to information that we need to track in project site, and also back into Tekla structures, where these issues are going to be followed up and then rectified. And again, like I mentioned with the statuses, we also have this direct link in Tekla structures for our BCF topics. So we'll be able to see these updates come through essentially live to Tekla. As I come in and load in the tool itself, it will then tell me what the current statuses are, or if there are any issues and so on. Let's just pick this out. We can see here it's gone straight to the panel that I want to go and look at. It's isolated it for me very quickly. I can then follow up with any information, add my comments and so on, and go from there. So you can see how this connected workflow then enables us to be more efficient, sending our information through to production, checking those things that have gone to production are correct and ready for being built, made, and then tracked through their life in order to make sure any issues are taken care of, and they are all logged and recorded in our document control software project site, where we can also go through procedures for checking our elements offs with checklists. For example, here I can come and say, look, I've got a particular unit that's gone through production. I'm going to do my Q&A. I can take photos with this. This will also work through the mobile platforms. So the guys that are in the shop floor can then check off, take photos, and then click into these different checklists and say, yes, we have completed these works. There we go. So I'm going to finish off here, and I'm going to hand over to our colleagues, Aidan and Ben, from Punch Consulting Engineers, and they're going to run through how they're using Tekla structures as a platform to then further develop tools for automation and precast industrialized construction workflows. So thank you for myself, and here's Aidan and Ben.
Hi everyone, I'd like to welcome everyone here today. My name is Aidan O'Connell. I'm a director with Punch Consulting Engineers. I've been working with Punch Consulting Engineers for over 25 years, and I'm the head of the Precast Operations Director within Punch Consulting. Our journey in Precast began back in 2017 with Kilsarn, and what I'll go through today is a presentation on the service offering that Punch do and what we've developed over the course of the years, and then Ben, my colleague, will give a presentation on the innovation that we're bringing into and optimization we're going to bring into how to reinforce the precast panels. Given that the residential blocks are pretty standardized, there's an efficiency there in relation to getting reinforcing of precast panels and using AI to do that. So the introductory, as I said, will go a small little bit in what we do.
which I will go into. So we normally start the model in Tekla Structures Designer and do a 3D element. That's one of the blocks that we have there. This allows us to go through any structural issues, panelization, facilitates load takedown, design and detailing of the precast building, and kind of get a bit more understanding of the building in a 3D environment. From that, then, when we have that modelled, we obviously do our design and fabrication drawings, and as with that, then that feeds into Kilsarn's plant. That's one of the most automated plants within Europe, and it's a Progress Group plant that we feed into. So you can see there the level of automation that's within the plant in relation to reinforcing and detailing, and how the factory requires it in relation to facilitate the way they automate the reinforcement within the precast factory. So we spent a lot of time developing the reinforcing and the detailing rules around these reinforcing panels. That's very standardized, and we obviously give that information to the factory to allow the automated factory process that information. So as you can see with the buildings that we have and the panels that we have, there's a lot of standardization in the process, and that process we are looking to see, is there avenues into automate the precast thing on it, to kind of get a bit more get a speed up the production of the mold and fabrication drawings. So on there you can see that we use Tekla Structures to do this, and we obviously coordinate the whole panel, do the design drawings and the GAs, and give that to the design team. When that all signed off, we get into reinforcing and detailing of the panels itself. So you can see here that one of the panels we'll take out, and we'll just show you that it's all done in a 3D environment. The abetments, the reinforcing tools, which is nothing really new within the precast industry, but it allows a higher level of coordination, I suppose, and rebar and clashes and checks within the precast panel itself, just to minimise any issues on constructability within the factory that would obviously have a serious impact on the production output from the factory if things were clashing and causing issues on site when they're fixing the reinforcement into the molds. So we detailed the whole model, all the reinforcement for all the elements. This is just to ensure that fully coordinated, there's no clashing, no issues, and that everything fits on site, which obviously minimises wastage and ticks the sustainability box. So it's obviously for a large apartment block that you can see there, it's quite onerous in relation to detailing every panel to ensure that everything fits. So we're trying to look at ways outside of the tools within Tekla Structures to optimize how we do this and how we reinforce these panels, because there is a lot of similarities between apartment blocks and what's required in relation to OPs and balcony connectors and grout tubes and other embedments within that, and the reinforcement that is required. So with that, Ben will go through how we optimize our tools to deliver this reinforcement outside of Tekla Structures traditional method into more to an AI method to do the reinforcement production drawings. So to give you a flavour then of the kind of scale and the jobs that are in the Irish residential market at the moment, you can see here a project that's carried out by Connacht. It's a Marina Quarter as positioned in Cork. So all of that was done out of that automated factory in Kilsarn. We do, as I said, the GA drawings. We coordinate with the design team, with the contractor, all the services and the OPs. Then we do the mold and fabrication drawings and send them to the factory, and that then allows us to go then to site when it's been erected to carry out the inspections on site.
So I'll hand you over to Ben, who will go through the really interesting point, I suppose, in relation to the automation and the advancements we've done within Punch Consulting Engineers to speed up the production of reinforcing drawings within Punch. Thank you.
Hi everyone, my name is Ben Geary and I'm a second year software development student in M2 in Cork. Over the past 2 years, I've been developing the Tekla API with Punch, which is now a Covey company, mainly focusing on automating the reinforcement of precast walls, while also ensuring the reinforcement we generate meets the production requirements of the Progress Group robotic manufacturing system. Before I go into the actual reinforcement automation, I thought I'd give a brief overview of what the Tekla API is and how we use it here at Punch. In simple terms, the Tekla API allows us as software developers to connect directly with the Tekla structures model using code. So instead of manually carrying out operations in Tekla, we can create a software that connects to the Tekla structures model, extracts the information from the model, and we can use this information to manipulate reinforcement based off our own logic. So this is extremely useful for things like grout tubes. So when you're automating reinforcement, you obviously don't want rebar going through grout tubes. So what we can do is we can scan the model, we can extract information about the grout tubes and their position in the wall, and we can manipulate the reinforcement around the grout tubes. Now this is different to the traditional custom components that take out a lot of repetitive tasks. While custom components are very useful, they do not always respect the objects in the wall. So this is the reason we went with the Tekla Open API for automating reinforcement, as things are constantly changing in the wall, and also different precast walls have different reinforcement parameters. So the API gives us this flexibility that custom components do not. So we can define the logic, interact with the model, and create the reinforcement based off a detailer's requirements. So I'm going to show the automation now that we've created using the Tekla Open API, and I'm going to demonstrate how we use it here at Punch. So to start the reinforcement process, we first select the wall in Tekla. The Tekla API itself allows you to interact directly with the objects within the Tekla model. So our current software interprets the geometric information to display a 3D render of the wall within the current user interface, with all the reinforcement automatically applied to it. Now this is a massive benefit from a detailer's perspective, because they can automatically readjust the reinforcement if needs be before ever actually inserting it into the Tekla model. So this 3D view is bridging the gap between the user and the actual software. So in terms of the actual user interaction, we decided to keep this extremely simple. So the user selects the reinforcement that they would like to change, and in the current UI it shows up the specific reinforcement parameters. So the user can simply change the reinforcement and it automatically updates in the user interface. Now, as you can see, for this specific type of reinforcement, there is actually a zone defined. Now, this is one thing we focused in on at Punch, as it gives the user a visual interpretation of where the reinforcement is actually being changed. So underneath all this, Tekla works off a coordinate system. So the original geometric information that we extracted is constantly being updated and used. Now this is a big benefit of the Tekla API for a specific automation like this, as a detailer is constantly changing the parameters in order to get the reinforcement output that they would like. Now from a software development point of view, this is extremely useful, this coordinate system, as it gives us the flexibility in order to manipulate the objects to how the detailer would like them in Tekla. So as you can see, this zoning logic is applied consistently throughout the user interface, with custom zones defined specifically for the reinforcement that you are editing. So as we developed the software, we had the ability to incorporate features based off a detailer's feedback. So one of the features that we were told would be extremely useful is this sort of deep beam logic, where the horizontal mesh comes to the inside and the vertical mesh comes to the outside. So simply through the click of a button, the user interface automatically adjusts this. Another feature we were told that would be useful is the changing of the restraint bar positions. So simply in the user interface, you change it, it automatically updates. So again, it comes back to the functionality of the Tekla Open API, and the flexibility gives us as software developers to define the features from the detailer, but also meet the requirements and the parameters from the Progress mesh machines that we use here at Punch. So one of the biggest issues we faced was the lack of a naming convention for the cuts. So when you extract the geometric information at the start, you're often extracting the bounding box of the wall and the coordinates of the cuts. Now, more often times than not, it's very easy to filter cuts by size, for example, openings. But what we were finding was some cuts were the same size, the same name, but they had different reinforcement requirements. So in order to combat this issue, we added in the user interface this ability to change the cut name, and it will automatically adjust the reinforcement. So for example, if you have a hidden column, it's going to reinforce it as a hidden column, and if it's a balcony cut, it's going to reinforce it differently. So this sort of flexibility in the UI is another thing that we added in order to give the detailer a quick and easy decision, but also improving the overall speed of the detailing process. So the issue with the cuts came up again when we were defining the reinforcement logic for the trimmers. So we found that different cuts had different trimmer arrangements, and that the software could not with certainty define the actual trimmer configuration for a cut based purely off the cut geometry. So what we did in the software is we defined the starting and ending zone for a trimmer, and we left that decision up to the detailer in the user interface to do. So in the current user interface, when you select the trimmer, it gives you this option to go through the different trimmer zones that the software is after defining, but it also gives the detailer a choice to maybe change the trimmer size, add a bin to the trimmer, what bin size they would like, etc. So again, you're bridging the gap between the detailer and the software. You're giving the detailer more choice, but again, it comes down to the functionality of the Tekla API and why it's so useful in developing the Tekla API for solutions like this. So far, I've demonstrated the individual features of the software, but I haven't really gone through the software in its full extent and entered the parameters and showed the reinforcement going into the wall. So I'm going to do that now and demonstrate how the software works and how we reinforce the walls and how quickly the automation process actually works. So we're going to simply select the wall. It's going to render a 3D view, and then I'm going to start entering the parameters. So there's this tapered end feature, which also reduces the spacing when it comes to the top of the unit. Same concept for the header mesh. It has this sort of feature in it. For the vertical mesh, change the spacing, and then it'll automatically keep the cover while also adjusting the spacing. For the trimmers, head in the bins where you need to. And that's the wall detailed, and simply you type rebar. And you will see it automatically populates the wall in Tekla with the reinforcement detailing standards. Now, one thing people might have noticed already is that the software does tend to adjust edge cases. So there's specific detailing requirements that some walls just could require a detailer, and the software automatically adjusts them. Now, this can be frustrating from a detailer's perspective because no detailer wants software automatically adjusting things in the wall without them knowing why it's done certain things. So what we've actually built into the UI, before you ever insert the rebar, you can actually check the edge case parameters. So if you actually click on the wall, it shows what edge cases were applied. So this is an edge case here. So this was the before and why the software actually adjusted. So the bar up here was coming too close to the cover. So the software automatically adjusted and added in the loose parts. So something like this is really nice from a detailer's perspective because it bridges the gap between the detailer and the software. So something like this is really nice to integrate into a software like this and saves the detailer the frustration and the why things are happening.
Hi everybody. We hope you found that useful. Just before we go into Q&A, please let us know if you'd like to speak with us at Trimble. So whether that's a chat with sales, the technical team for Tekla, or project site, or even if you just want more webinars and you found this useful. Okay, thank you everyone for the responses. We'll leave it open for a little longer as there's some responses still coming in. Thank you everyone. We'll move on to the Q&A and I'll go ahead and look at the first question. We have an anonymous question for Punch. So Punch, how have you found the interoperability of Tekla as a platform for driving an automated precast facility? It is clear that you have developed very efficient tools, but do they translate to fabrication well when passing through the software? So it's broken into two.
Yeah, so I'll just answer that there. Hi, Aidan here again. So yeah, so within Tekla Structures itself, it has a lot of automating tools that we do use. There's no point developing those because they're sufficient enough. The reinforcing tools that we have developed, they do transform to fabrication well, because one of the key things is for the automated factories is that the reinforcement is done in a very specific way. So by automating a lot of the reinforcement, you take a lot of the headache out of the fact that something could be detailed, but the machines in the factory mightn't be able to read it during the checking stage. So during the development of the reinforcement in the panel, you kind of overcome the issue that you won't end up with a panel prior to going to manufacture that has errors in it that can't go into manufacture. So the API, we have been on that journey for I don't know a small while now to develop this. What you saw is one of the more complicated panels that we probably would get, and we do find it very, very useful and implementing it. And we will be developing more efficiency tools to increase that side of reduce errors, reworking, and get more efficiencies out of Tekla structure.
Thank you very much, Aidan. So a question from Hamza about getting a copy of the presentation. Yes, so all attendees who registered for today's webinar will get sent a follow-up recording of today's session. Just check more questions. So we have a question here for once structural models drawings are released from Tekla, how does project site help production teams handle quality checks, track completion status, and log any issues on the shop floor?
Yeah, so I think I'll take that one. Yeah, so with project site, once we've actually got the drawings sent through, like we've seen on the presentation earlier, the hub of Trimble Connect allows project sites instant access to these files, and they can be pushed through for document control, approvals, and then status checking. So, for example, we're able to use the platform not just in the office via the web app, but also on site on our mobile apps, allowing teams to go and actually check whether they be production checks like we saw earlier with our checklist, or if we're looking at installation, for example, we might be following it through to actually going on the site and going through and checking that the installations have been successful, or if there have been any issues, we can run snags, snag list, issue lists, and so on via the project site tools, which are then relayed back through to the relevant teams that would require to sign these off. So it enables us to keep a track of all of that sort of information as it's being recorded on site in the factory, in the office and keeping a central single source of truth, as we say, of all of that project documentation. So it keeps everything locked down, easily accessible and auditable, so you can actually go through all of this information and keep track of exactly where your project statuses are. So I hope that helps.
Thanks, Stephen. They've got a couple more questions to go through today, and if there is more questions, please continue to pop them in the Q&A, and we will follow up with anyone who does ask a question following today's session. But we've got 5 minutes left of today's webinar. We have a question from Anton. How do you add additional bars? For example, corner trimmer bars at 45 degrees at the opets.
I can take that. I suppose I'm presuming it's in relation to the tool and the tool that we've developed. So currently we just use the Tekla program itself to put the bars in at the 45 degrees. It will be an add-on feature to what we developed there in order to automate the reinforcement around openings. But yeah, that's that. Like that tool that you saw there is relatively new, and it's still out of the testing phase, really.
Thank you, Aidan.
There are also, if we're looking at doing this in manual, so if, let's say, for example, Aidan's tool's gone so far down that line where it's given you, you know, the design requirements that you saw just a moment ago, there are also additional tools inside Tekla that you might well need to utilize in order to put those corner trimmers in, or additional bars that you could obviously align to those cuts and openings and so on. So there's a diagonal reinforcement sort of function in the wall layout, wall panel tools. There's also in one of the rebar openings and edge tools as well that could be sufficient. But there's also the standard rebar modeling as well. So in some cases, you might end up coming back to the point with which you would just model that rebar in. But thankfully, obviously, the tools are there. They're extremely intuitive and efficient. So, you know, it's one of those things where we can always do it. There's always a yes to that question.
Thank you, Stephen. Question from Sriram. So, is there an automation tool in Tekla to check that embedded objects added to the respective panels and their positions are assigned correctly based on the cast unit form face?
Sorry, go on, Aidan.
No, you can. It's okay. What we've developed is that you assign the form face and then you automatically put your embedments in via Tekla structures, so that it kind of gets over that issue. But I don't know if there's I don't know if it does anything more than that. You want to?
Yeah. No. So I was going to say, so that's essentially taking that, you know, to the next level. You know, that's the whole point of essentially the API, and where Punch and Aidan and his team have taken some really good ideas and pushed them forward in order to negate maybe these issues. But then inside Tekla structures itself, there isn't a specific tool designed directly at this checking procedure. However, there are certain things that you could put in place in order to at least flag these elements up, utilizing different processes through the organizer, through the certain tools. For example, there's an embed placement tool, embedded anchors, which can be used for very many different insertions, whether it be demolders, sockets, lifters, and so on. And these things will allow you to automatically place in a specific let's say UCS of an element that you're putting in, so it would automatically force this to be in a particular direction, and then you can use the object representations to then check whether these are correct. You would need to put a workflow in place in order to do that, but you could possibly come out with that requirement. However, if you wanted something very specific, then the API would be able to check this out for you.
Thank you very much, Stephen, and thank you everyone for your questions. Anyone that we haven't answered, we'll try and follow up with today. And thank you for taking part in the poll, and have a great rest of your day, everyone. Thank you.
Thanks.
Perfect. Thank you very much.